So we've done a pie and we've done a donut pie. And another element that is really important when you're doing a pie is to put the legend. And the legend is usually being done by putting line on each category of the pie and then give the label. So in this section, what we're going to do, we're going to create a new pie, and this is going to categorize animal, at a zoo, for example, and each category represent how many. It's a numeral counting of how many of that animal we have at that zoo. So for example, at the first glance, you can see that we have more cats than dogs. We got more horses than any other animal category, and it really highlights how pie chart and donut chart is able to give you that 10,000 foot overview of what's happening with the simple quick glance at the information. So we're just going to create a new chart and we're going to put the labels on our donut chart. Alright, so let's create our project. We're going to be using the create React app template must-have libraries. So let's copy the command and put it in terminal. For the project name, let's call it donut chart. So replace your project name with donut chart. And I'm gonna pause the video until the libraries and the installation is complete, so hold on. A good place to start is from the data. And the data, I just set up some random animals and number that can represent the animal count. So if you look at the CSV, we got a name for each animals, and we got values that I set up that it's like a count. So for example, we got, as we said, for example, if we have a zoo and we got 15 dogs in the zoo and 25 cats and 30 horses. So I'm just giving names for the category and represent them by a count. So that data, I'm gonna put it inside of public data, and I'm gonna call it donut CSV. And this is really a good place to save it because it's going to be accessible easily. Next, we want to create a widget, and we want to create our component. So we'll be using the template that I have. For the widget, you could see the command. If I open the README inside of the component, it gives us the D3 widget component template. So I'm going to copy that, and I can put it in terminal. For the name, change the name from line chart, and we're going to call it donut chart, right? So this is for the widget component, and then we need to do the same for the widget. So I'm going to the widget folder, and instead of the README, here is the widget template command. I'm just going to open up another terminal, and instead of line chart widget, let's call it donut chart widget. All right, so we got our widget got created, and our component widget got created. Next, a good place to really start working on the component is to set the types. So if we go to the component donut chart instead of the component, right, we got the helper. So we'll work on the helper, and we're going to work on the types. It's a good place to start. For the types, if you remember, we have only, again, let's look at the CSV data donuts, right? Our metrics are name and value. So just change here to the data type name and value. The name is going to be a string, and the value is going to be a count of number. The dimension, we're going to use that. So we have it all set up here. So that's about it. Now the next step is really for us to work on our donut chart helper, and we need to do a few things. If you can see, we have all this pre-populated code. We don't need to use all of it. We're not gonna be doing anything with date, so we can delete this comment. Then for the metrics, it's set up correctly. The x accessor is gonna be the value, the name, and then the y accessor is gonna be the value. So that's set up correctly. Now for the scales, we're not gonna be using the x and y scale because we're using a pi. But what we can use for our scales is we can create a color scale. So we can delete all this code and let's create a color scale. And the color scale, what we can do is we can just have some random color maps be chosen for us. So I'm going to show you how we're going to do this. So what we're going to do is we're going to use D3, and then we're going to use the scale of type ordinal. And then our domain is going to be, we're going to use the D3, and we're going to extend our data, and then we're going to map through our data to create our color scheme. So we're going to return the name, and then we're going to use that as a string. So first we need to convert it to unknown for TypeScript because it doesn't know what type it is. And then we can cast it as a string. So we need to wrap that in a and after we cast it as a string, then we can use the, I guess it doesn't need that. Then we can use the range, and then we can use D3. It has that schema category, all those schema categories of colors. You could see how many, so we can pick anything we want. I'm just going to pick the first one because we just want to get it working. We got to close the string here. Let me see. Okay. Let's move this to the next line. Looks like I got an extra bracket, so let's delete that. All right, that's it. So now our helper is ready. All right, we can close the helper, we can close the README. Then let's work on our on the donut chart and the donut chart widget. Let's start from the widget and let's make sure it's all set up correctly. You can see I left you a comment here in the template that it needs to point out to the correct component. So our component is the donut chart. So it needs to use the donut chart, and the component is donut chart. And for chart, we can refactor it to call it donut chart. And for the helper, also it needs to be component, donut chart, and donut chart helper. Okay, now we can take the comment out. And for the properties name, we got name and value as the default, which actually match our CSV. So we don't need to touch the metrics, it's set up correctly. For the dimensions, we have it as default as 0.9 is width and height is 0.9. We can leave it for now and change it later, that's okay. And for the loading of the component, we can just use D3, so we can delete that comment for JSON. We're not going to be using JSON, and we just need to point to the file name. So the file name is donut.csv. There we go. Then for the chart name, it needs to match our import. So it's donut chart. So just we'll change that. And for the title, we can just call it donut pie chart. And that's about it. Just make sure there's no errors. So let's look at the problem, if there's any problem. No, looks like everything is okay. There's no errors. So that's really all that we have to do for the donut chart widget. And this architecture is really great because it allows us to, put in the JSX any type of component, and we can share the same data. So we want to really avoid redundancy. So we want to load the data in our parent component, which would be the widget, and then we can put any other component. If we want a list here, if we want other component that share the same data, we can just put them here in the JSX. At the app TSX, that's our entry point, we want to add our widget. So just delete whatever you have in the header, and let's just put the donut chart widget and make sure it's imported. There you go. And then now that we got our entry point, we got our widget ready, our helper ready, our type ready, now we can work on our donut chart itself. And there's a few things, a good place to start is really, let's look at the JSX. And our JSX, the template already set up with a div and a wrapper and the bounds that already has the transformer translate. The wrapper already has the dimension width and the dimension height, so we don't have to touch any of this stuff. The only thing we need to do here is really, let's get rid of our X and Y axis, because we're using a pie chart, so we don't need to put any peripherals for the X axis or the Y axis. It's not necessary, so just delete that. Now we can go up to the top of our component, and you could see two things. We got two methods here. One is the memorize draw callback and the memorize update callback. The memorize draw callback is going to get called every time there's a change, for example, in the width or the height, or the first time the component is initialized. And really what we want to do is we just want to do a cleanup. So this code is good to go. Really what we need to do is we need to use D3, do select, and then we need to select the chart group. See, it's right here. That's where our pie is going to be, and we want to clean up everything inside so we can draw a new one. So I'm just going to use the default code that I set up for you. So I'm going to select the chart group and select all the elements inside and remove them every time there is a resize or the first time the component gets initialized. And then the memorize update callback is going to be called next, and we're going to use the scales because we set our scales with the color, so we need that. We need the bound. The helper, we don't need it because we're not going to change the metric, so we don't need to create a new instance of the helper. We can just use the static element, so we can delete that. It's not necessary. And then the other thing we do need is we need to calculate our radius. So let's create a constant and let's call it radius. And what we can do is we can use math and we can check what is the size of the width and the height. So we can take the dimension width and we can compare it with the height, and then we're going to take the minimum. We're going to take the smallest size. So let's put dimension height, so it's the same prop dimension and height. And then after it does this, so the math min is going to take the minimum, so if we set different width and height, we need our pie to fit inside of our page. So we cannot have the pie exceed the dimension. That's why I'm using the math min. So I'm going to take, if you resize your browser in a weird way and it's not a square, then it's going to take the minimum size. And then what we need to do is we need to divide that by twice the size of the margins, because we have the two margins that we set. So I'm just going to use the left margin, or you can just do minus the right margin and the left margin. So I'm going to use just the left margins, but again you can do divided by the left and the right, but this is good for what we're doing here, because we need to remove the margins, otherwise it's going to occupy the whole screen. That's what we set the dimension with the margin at the widget component. And now that we have the radius, we need to create our pi, and it's going to be really an SVG. So we can create a new constant, let's call it pi SVG, and we can use the bounds to set it there. So what we'll do, we'll select our chart group. If you see, again, go back to the JSX, we have the chart group. So we'll select the chart group, and then we can append our SVG element, and we'll set some attributes. What we should set is the width and the height. So let's set the width, and we're going to use the dimension that we set in our parents component. So we'll use the width from our dimension, and we'll do the same for the height. So that height, and we're gonna append a group element and give it a transform using the translate. Since we're using attribute, we need to make sure that we then we don't need to use pixel. We can just use template style and put a translate, and let's use the props dimension width divided by 2, because it's a pi, we want half of that, and the same with the height. So we want the height divided by 2 for a group. Oops. See what happened here? Yeah, it went to the bottom of the document, so let's go back here. Okay. Height and divided by 2. And again, we don't need to put pixel because we're using attributes, which is better than using the style. Many times I forget to put the pixel, and then it just doesn't do the transform correctly. So now that we have our pi SVG and it has inside, it's using the chart group as its parent component, and we added an SVG and we added the group and we have a transform, then we can really start working on our pi. So we can take our, we can create another variable, it's called pi, and then we can use the d3 pi API, and then we can just use the value and map the value of the data to be the value. I can cast, it's probably TypeScript is going to give me an error because it doesn't know the D type, so you can, cast it at that type. I'm just going to ignore that for now. And if you would need to do a sorting, some kind of sorting, so the API has a sort, so you would put the type of sorting we need, or if you don't use it, you can just leave it null. This is if you need sorting, so I like to leave it here just in case in the future I need to kind of do some kind of sorting. So now that we have the actual Py and what the Py does, look what it does. It's using the D3 API Py, and then it takes it iterate through our data, and it will pick the data value, but it's not doing it yet. We're just setting up our constant, then we'll assign the data, and then it's going to loop through that. And now what we can do is we can create a constant, and let's call it Py data, and that will use that Py API we created, and we just pass the data, and that will push the data through our Py and iterate through each one of the data. It's going to map it, and it's going to use the value, so the Py data will we can use that. And now that we have the Py data, the next step is for us to create the arcs. So for the arcs, what we're going to do is we're going to create a new constant that's called arc, and then we're going to use the D3 arc API, and this will create those the actual Py, the actual circle, and it takes it really needs two properties. It needs the inner radius, and that needs to be and it needs to be the outer radius. We have inner and outer because we're doing a donut. If we're just doing a Py, then we wouldn't need the inner, right? And the inner, we can just use that radius that we set up. If you remember at the top, that is doing the calculation of the size of the Py that we want. And what we can do is we can use the radius, and then we can multiply that by half, so it's half the size, because again it's a Py, so we want half of the size, so it will fit the screen well. That's the inner. We don't want it to be the whole size. We need, but you can change that. Once you set up those values of the inner size, you can play around with the values. I'm doing is 0.5, but if you play around with those numbers, you'll see it's going to look different. And for the radius of the outer, let's use, instead of a whole, let's use 0.8, so it doesn't take exactly the whole screen, so it's going to lay out nicely for us. And now that we have the arcs, we also need to create arcs for the label positioning. So for the polylines and for the labels, what we do is we create another arc, and then we can position using that arc to position our polylines and our label. Let's take a look. What we'll do is we'll create another constant. So we already have the arc, that's for the Py, and we can call this an other arc for, I'm going to do it all camel case, labels position. I like to use Shakespearean naming convention, because it's this way you don't need to leave comment, because the name tells you what that constant is doing. And then again, we're going to use the D3 arc, and we're going to set, just like we did for the Py, we're going to set the inner radius and the outer radius. And we need to make it a little bit bigger, because the position is above the beginning, but you can play around with the values and see what you like. But if we want to position it a little bit, we don't want to position it right at the beginning of the inner radius, then we'll use a bigger radius. It will position it nicer. So now that we have everything, we can really start drawing the chart itself, the Py itself. And what we'll do is we'll use the Py SVG, and we're gonna select all the element, and we can give them a name. So we can give it a name of, let's say, all slices. So this is gonna draw the slices for us, and then we can pass the data of pie data that we set. And to actually do the drawing, we need to append a path element, and we need to set the attribute for the data as the arc that we set. So that's needed for, to create the slice. It doesn't know the type, so we're gonna have to wrap it with for TypeScript, we're gonna have to wrap it in a tsignore if we don't want to go through the effort of figuring out the type. And then the other thing we want to do, we want to start styling it. So for the style, we can use an attribute of fill, and for the fill, we have the scale that we created. So what we're going to do, we're going to use the data, and then we're going to use the scale we created. So we're going to, on the data, we want to return a different color. And for that, we're going to use the scales, and it's the color scale. And then we're going to pass in the D, which will have the data, which will have the name. So it's gonna pick for us a random color using what we created. We can actually do it like this in one line. I hope I don't have any errors, but it's more neat. It doesn't know, again, the data type, so we're gonna need to wrap it with a tsignore for TypeScript. The other thing we want to do is we can set a stroke to kind of have a stroke around our slices. We can use, I'm going to use a white color, and oops, I have a typo, stroke. And the same, we can set up an attribute for the stroke width. What's the width we want, and we can give it 2 pixels. We don't want it, to be too big. Even 1 would be okay, but 2, it's a little bit better. And then we can set the style for the opacity. This way, it will blend better with our page. So that's it for the pie itself. And now we can work on our peripheral. You see, we have all that y-axis and x-axis is the default code. We can get rid of it because we're not going to draw y and x-axis for pi. It's not necessary. For the peripheral, what we want to do is we want to create the polylines, and we want to create the labels. So again, we're going to use the pi svg as our element, and we're going to select all just like we did here. Actually, I'm just looking at the code. Looks like I'm missing a code. We need to, after we set the data, we need to tell it, then on enter it needs to append. So don't forget to add that. And the same here, right? So we need to select all. We can give it a name. Let's call it all polylines. And then we need to set the data. The data is the same, right? The pi data. And we need to make sure we have the enter. So on enter, we can append our polyline. So we'll add a polyline element. And And now we can set all our attributes. So we'll put a stroke attribute. We can give it a stroke color of white for those lines, and the width, for the width I'm gonna give it a stroke of 1 because we want like a nice small line. And now what we need to do is we need to deal with the points for our to draw the line. So that's a little bit, we need to put some calculation to calculate the points in order to draw our line. So we'll use the attribute of points. That's part of the Polyline SVG. If you look up at at the SVG API, you'll see for the Polyline, it's expect points that will define the coordinate of each position of the line. That's how we draw the line. So we got, the X and Y. So we define all the X and Y points that will draw the line for us. So you can, I'm just drawing, a simple line, but you can make, whatever design you want. We're just keeping it simple, but you would just change the points to whatever design you want. You can, you can put whatever line design or any, different design that you want. So to do that, we need to just put all the points, and we need to calculate all the position of the point. So we're going to do a few things. We're going to go and take our data and map that in few things. So we need to do all the calculation. So we can create a constant for the first position, and then this, we have really 3 positions. If you look at our donut pie chart, Polyline, we got 3 positions. We have the first position in the center, then it goes up, that's the second position, then it goes to the end. So we got 3 positions for each line. But again, if you want to keep it more simple, you can just do 2 positions. You can put it from here to here. It's just neater with the 3 position. And because of that, we need to calculate those 3 positions. The first position, we can use D3. It has an API called Centroid, and what it does, it's just gonna it's gonna insert inside the line, inside of the pie, it's gonna insert the first position, and it doesn't know the type. So again, we need to wrap it in tsignore. So that would be our first position. Then our second position, position B, and we're going to need position C. Okay, so our second position, we need to do, what we can do is we can take our other arc that we created. So if we take the other arc, label positioning, and again we can use the center of it. So center it, the centroid with the data, that will center it to that other arc we created for the labels. And for the third positioning, what we can do is we can also use the same label with the centroid, and we're going to use the same one because the position of the third element is almost the same as the second element. So if you look at the polyline angle in terms of the y, it's on the same y as the position B. So it's the same position as here, the y of the line, but the x is all the way skewed either to the right or to the left. So to do that, we need to just calculate the x, and we'll do that with a pi. Let's take a look. What we're doing is we're gonna set the position C as the same as the other arc label, and then we're gonna create another constant, and we can call it mid angle to figure out if it's on the either side of the extreme. And D3 is gonna assign to our data the start angle. You can see it's already included, and it's gonna have the end angle, so we can just do a calculation of the start plus the D end angle minus the D start angle, and we can divide it by 2, and this will help us figure out if it's on the extreme end of where it is. And using all that stuff, we can now calculate the position C, the third position, x value. The x value is the first, right? Because the position C will have, it's an array of x and y. So the position C 0 will be the x location. And what we can do is we can use our radius that we created, multiplied by 0.95, and we can use a pi using our mid angle that we created, and see if it's less than math pi. Pi, if you remember from high school, is it's a circle, so we need to figure out the pi, and if it's greater, if it's less than the pi, then we'll assign it a 1, so it's multiplied by 1. Otherwise, we're going to multiply it by -1. This way it will go to the either side of the either left or right. And now that we have all the calculation ready, let's see why it's complaining. Oh, I have a type. It's lowercase, not camel case. And now that we have that all set up, what we can do is we can just return those positions. So position A, position B, and position C. Errors. Let's fix all the errors, and we can actually run it if we want, even though it's not complete. So let's see all the errors we have. So dimension, it needs to be margin left. That will take care of this. Here it looks like I have an extra space. What else? The pi data, we need to wrap it with a TS ignore because it doesn't know, TypeScript doesn't know the data type. That will take care of that. And the same here, it doesn't like overload, so we need to wrap it with the TS ignore. Because TypeScript add elements to the data, and it's supposed to be, you're not supposed to do that according to the ESLint rules that it's set up on this project, so it doesn't like that. Let's see what else going on. Position C. I did a constant. I'm redeclaring position C, so I need to take off the constant. Here I have post instead of position on the B. Alright, we're down to one error. Let's see what it is. Here it's just the spaces. So the how it's been indented. That was okay. So that looks good. We have no errors. Now I was running yarn start and I'm getting an error here. It says value is not defined. Let's take a look. So if you see here, it's missing a dot. That's why it's not aligned right. So value needs the dot. Let's take a look again. Refresh. Refresh automatically. It's still not drawing. Let's take a look why. If it's not drawing, 9 out of 10, it's the transform. So let's take a look at the transform. The transform was right. You remember I told you that, you know, if you use a style, you need to use pixel. We're not. It looks like it's correct. The problem is here, if you see on the select, I'm using chart group. But this is, if you look at the JSX, the chart group is an ID. So for ID, you know, we need to use the number sign. Let's put the number sign. Refresh. Does it automatically. Here we go. Okay, great. So it's giving us the donut pie. It's giving us the line. And we have the 3 position of the line. But we got one problem. If you see, we have a style here. It's using, you know, if you don't set the fill style, it set it automatically. So we need to go and set our fill style. So we need to go to our polylines, and if you see, we set the stroke as white, but I didn't set the fill. So if I set the fill, and the fill needs to be set to none. If it's not being set to none, it's going to be set to the default, which is black. Let's take a look. Let's refresh. There you go. So now we got you know, donuts, we got our polylines, and the only thing we're missing is the labels. For the labels, we'll add it again to our py.svg. So do py.svg, and we're gonna give it a name of all labels. And we're gonna assign the data of the py data, just like what we did for the polylines. And on enter, we want to append a text element. And for the text name, we're gonna iterate through our data, and we're gonna return the data.name, and TypeScript is not gonna know the type, so we're gonna do a tsignore again. Okay, so that will set the text to, you know, to the name that we created. And let's see, it's complaining. On the return, we have to wrap it in those round brackets. Let me make sure. Okay. And now we need to position it, right? So now we have the text, we need to position it. So we're going to use the attribute of transform, and we're going to pass the data, and we're going to do really the same as what we did for our polylines. We need to but you know, now we don't need 3 position, we just need 1 position. So we're going to create a position constant, and we'll use the outer label position with the, and center it. I don't know if I'm pronouncing it correctly. But we're going to use the same. And then what we need to do is we need to calculate our mid angle. So create we'll create another constant for the mid angle, and we'll do the same as we did before. We're going to use the start angle plus the data end angle minus the start angle it's not recognizing it, 1 second. Because I'm recording, it really slows down the machine more on a laptop. So we'll put the start angle and divided it by 2 because we want half the position. See why it's complaining. We don't have a dot. Okay. And now that we have the mid angle, we can do the same as we did for the polyline, and we can take our position, but we really care about the X position. We don't care about the Y position. So we're just going to do, the same calculation that we did here. It's going to be really similar. With a little bit of a difference is that we want the radius, we want to skew it really to the middle. So I'm going to using 0.99 time the angle, and we get some errors, so let's take care of them. Here we get probably this is again with the overload that our ESLint is not set up for it. You can hover over, it's going to tell you exactly what it is. So we need to let D3 do its thing, and it will do the overload. So we have either the option of completely change our ESLint or just put some ignores. It's better to put ignore because this way we're kind of going through the code and we're making sure that what we're ignoring is really legit, and we're not just ignoring things that are important. We'll get one more error. Let's take a look. Here. This is what D3 does. It creates elements that it doesn't, TypeScript won't recognize, so we need to ignore that. So that's good code. All right. Now that we position it, we need to do few more things. We have the position. We need to return that position. So what we return is our, because this is a transform, then we return the translate. And using template style, we're just going to pass in the position and close it. So, okay, no errors. And then, wait, it does have one error. No, this needs to be template style. When you do the template, the dollar sign needs to be next to the bracket, otherwise it doesn't know that it's our token that we want. Okay, now it's good. Then we need to set the fill, and we need to set the anchor because we want to center it. So to center it, we'll use the text anchor property, and we're gonna iterate through our data, and we're gonna be using, again, we're gonna create a constant for our mid angle. That would be our start angle plus our end angle minus the start angle. So again, that's our center. And what we need to return is we need to do that check if it's on the extreme end. So if it's on the extreme end, so our mid angle, is it less than the math pi then we want it as the start for the anchor, otherwise we'll set it as the end of the anchor. Okay, no errors. And then the last thing we want to do is we want to put a style for our fill, otherwise it's going to use the default, which I think again it's black. So let's set it to white and let's compound. Let's take a look. There you go. So you know, we got our donut pie chart, we have our label position, you know, correctly on the same Y position of position C, just like with the polyline, and we have our pie chart, and you can play around with those properties, and you can also move those properties into the widget. But we got a, you know, a good looking chart, and you know, you can play around with the colors, you can play around with the properties, but this is really you know, a complete chart that also if we gonna resize it, you see, so it really handled the resize gracefully. The only problem that I'm seeing here is if you look at the horse, look at the position of the text anchor. So the text anchor can be either at the start, at the middle, or at the end, and it looks like it's miscalculating it and it's putting only the horse because it's one of those positioning that it should have been at the end, and it's not positioning it right. So let's take a look. So if we go to the all label element and we need to find that text anchor, and let's see what's happening. The mid angle, we're doing the start angle plus the end minus the start, but we want it to calculate the mid angle at the middle, so we need to divide it by 2. So I forgot to divide it by 2. Let's take a look again and refresh. There you have it. You see, so now the horse label is positioned correctly. So it's really, you know, having that good understanding of what's happening can really help you, because you may want to customize this chart. You may want, you know, different labels. You may want different polylines. You may, all those configuration. You really need, you know, really good understanding of what's happening here to be able to create your custom chart. But you know, it's a good looking chart. We didn't use any third-party libraries. It's lightweight, and you know, that's what we like. So here you have it.